The diagram shows an open rectangular tank of height h meters covered with a lid. The base of the tank has sides of length x meters and half x meters, and the lid is a rectangle with sides of length 5 upon 4x meters and 4 upon 5x meters. When full, the tank holds 4 meter cubes of water. The material from which the tank is made is of negligible thickness. The external surface area of the tank together with the area of the top of the lid is a meter square. In the first part of the question, I need to express h in terms of x and hence show that the area is equal to 3 upon 2x square plus 24 upon x. So in the question it is told that this is a rectangular tank with dimensions of x, half x and height h. This tank is an open rectangular tank and is covered with a lid. The lid has dimensions 4 upon 5x and 5 upon 4x. It is told that when the tank is full, it holds 4 meter cubes of water. So I can say that the volume of the tank is equal to 4 meters cube. It is also told that the material from which the tank is made is of negligible thickness, so I don't need to account over here the thickness of the tank. The external surface area of the tank together with the area of the top lid is a meter square, and I need to form an equation for A and show it is this. So the total surface area, which is A, would be equal to the surface area of the tank plus the surface area of the lid. Since the tank is open on the top, it is going to have 5 sides of which I need to find the area of. The area of a 3D rectangular box is this, but since this tank is open from the top, I don't need to account this area. So there are a total of 5 sides in this tank, of which I need to find the surface area of. This height and this height is the same, so this is h. So the area of the front side is going to be xh. And the area of the front side is also going to be equal to the area of the back side. So it's going to be 2 times xh plus the area of this side, which is going to be half x times h, and the area of this side is going to be equal to the area of this side. So plus 2 times half x times h, and plus the area of the bottom side, which is this. The area of this side is going to be x times half x. Simplifying this equation would give me the area is equal to 2xh plus 2 divided by 2 is 1, so plus xh plus x times half x is half x square. 2xh plus xh is 3xh, so the area is equal to 3xh plus half x squared. Right now this area is in terms of x and h. The equation that I need to show this in is in terms of x only. So this means I need to form an equation of h in terms of x, and I need to substitute that equation in place of this h. So for that I am going to use the fact that when the tank is full, it holds 4 meter cubes of water. So this means that the volume of the tank is 4 meters cube. The formula for volume of a rectangular box is length times width times height. So the volume of this rectangular tank is going to be x times half x times h. So it's going to be x times half x times h. And we know this is equal to 4 meters cube. X times half x times h is half x square, h is equal to 4. To form an equation of h in terms of x, I'll make h the subject. So it would be h is equal to 4 times 2, which is 8, and divided by x square. This is the equation of h in terms of x. Now I'm going to substitute this equation in this equation, and that would give me the area is equal to 3x times 8 upon x squared plus half x squared. X divided by x square is 1 upon x. So the area is equal to 3 times 8, which is 24 upon x plus half x squared. This was the equation that I needed to show. So this is the answer to the first part of the question. This equation is shown. For the second part of the question, it is told that given that x can vary, find the value of x for which a is a minimum, showing clearly that a is a minimum, not a maximum. So when it is said that a is a minimum, it means a has a stationary point. And for stationary points, the derivative is equal to 0. Right now the equation is in terms of x. So I'll need to find dA upon dx, differentiate a with respect to x and equate it to 0. Because at the stationary point, dA upon dx is equal to 0. So in order to differentiate this, first I'm going to rewrite this equation in the form of 3 upon 2x square plus 24x to the minus 1. Now I'll differentiate this dA upon dx would be equal to 3 upon 2 times 2x plus 24 times minus 1 x to the minus 1 minus 1. 3 upon 2 times 2 is 3. So dA upon dx would be equal to 3x, and 24 times minus 1 is minus 24, and minus 1 is minus 2. So x to the minus 2. Now at stationary point, dA upon dx is going to be 0. So 0 is equal to 3x, and minus 24x to the minus 2 I can write as minus 24 upon x squared. Sending 24 upon x square on the other side would give me 24 upon x square is equal to 3x. Cross multiplying would give me 24 is equal to 3x cube. Dividing the equation by 3 would give me x cube is equal to 8. And when I take cube root on both sides of the equation, this cube cancels out with this cube root, and the cube root of 8 is 2. So the value of x comes out to be 2. This is the value of x for which A has a stationary point. In order to find the corresponding value of A, I'll put this value of x in the equation, and that would give me the value of A at the stationary point. So A is going to be equal to 3 upon 2 times 2 squared plus 24 upon 2. Calculating this would give me the value of A as 18 meters square. So this is the stationary value for the area. Now to show whether this area is a maximum area or a minimum area, because the stationary point can either be a maximum stationary point or a minimum stationary point, I am going to find the double derivative, meaning I am going to differentiate this equation again, and the double derivative d square A upon dx square is going to be equal to, the differentiation of 3x is going to be 3, and for the differentiation of minus 24x to the minus 2, it's going to be minus 24 times minus 2 x to the minus 2 minus 1, which is minus 3. Minus 24 times minus 2 is positive 48. So d square A divided by dx square is equal to 3 plus 48, and if I shift this x to the minus 3 to the denominator, I'll get x to the positive 3. This is the double derivative. Now in place of this x, I'm going to substitute the value of x for which there is a stationary point. So I'll get d square A divided by dx square is equal to 3 plus 48 upon 2 cube, and this is equal to 9. So the double derivative d square A upon dx square is 9, which is greater than 0. And when the double derivative is greater than 0, the stationary point is a minimum stationary point. So this is a minimum stationary point, meaning that this area is a minimum area and not a maximum area. And this was what I needed to show. So this was the answer to part 2.